Hi everyone, my name is Łukasz Bromirski and I will be talking in English today about the dark networks, wars and communication as discussed with Adam previously. And typically we do deliver those sessions in Polish, but it's a confidence legends conference, so English is kind of almost like mandatory. At least that's what I thought initially. So anyway, I will be talking or focusing mostly on the two topics. One is the internet transport. And if you know me, I'm typically the routing guy, not so much security guy, but I would like to share with you some of the ideas about securing, well, first of all, problems within the internet transport, and then some ideas how to secure that. And then we will look at scaling out the protection for applications traveling over this transport, right? And during this confidence edition, you have a lot of sessions about applications and malware and stuff like that. And I don't want to touch this because this is kind of a fluffy topic for me, at least. But let's focus on those things that I believe I have something to say, and why traffic or inspection of the traffic without encryption, because this is hardly scalable nowadays, and I will talk about this later during the session. And at the same time, obviously, as Matthew Green said, at some point in time, we are dealing with security because it's hard, right? Some of the things we have to think about before the attackers will be willing to think about them. So this is why we are talking about stuff that typically doesn't matter for all kind of different IT and security departments, right? They like to decrypt the traffic and then make a decision if they should drop or allow it. So if you don't know me, I'm the routing guy. I moved recently. I was leading the technical organization at Cisco here in Poland. I moved 2 years ago to security business unit, which is essentially the team that is building the security products from Cisco. And if you would like to poke around, go ahead and target my site. Hopefully, you will not break anything that's not already broken. If you have any comments or whatever else, just go ahead. And I'm linking here the presentation director because I was already a guest at Confidence, and typically I was talking about network segmentation, the best practices for service providers, virtualization, stuff like that actually helps to secure the basic platform level traffic that goes throughout your network and then goes into the applications. I was also delivering a couple of sessions that did demonstrate how to actually attack the network and what kind of information defenders can gather from that. Obviously, the world move on because, as you can see, I was last present at Confidence in 2010. Right now we are 2021, but some of the topics actually haven't changed that much. So obviously everybody is talking about the impact of the COVID, right? And the COVID just demonstrated that everything can be moved to the internet-based, almost everything can be moved to internet-based connectivity. But the problem with the internet-based connectivity, or problem with moving that in a kind of quick pace in a situation where, for example, you have like 24 hours to move your entire workforce to work remotely without access to the office, is that actually some of the companies decided to implement something we call security by obscurity, right? And I do agree to some extent that it works in some of the cases. And there are a couple of interesting blogs around that showcase that this approach was effective in terms of slowing down the attackers, and I can agree with that. But then it doesn't really matter from the perspective of the big picture, because this is exactly the exercise I did like a year ago, and I just repeated this 2 days ago. Setting up a couple of honeypots or virtual machines, essentially listening to the IPs around the world. Some of the IP address space was never used or not used for the last couple of months. Some of the IP address space was used pretty frequently. And as you can see, just playing with the ports that SSH is actually listening to doesn't give you much in terms of the defensive posture. So if you want to implement something fast and your IT department or security department was not actually ready to start doing that kind of things, it seems that you may not have a big chances of surviving any kind of attacks by just implementing security by obscurity or not implementing anything at all, right? So right now, if you are, after 2 years, if you are still thinking in that kind of terms, in terms of your main strategy for company survival, just stop and start to really work on some of the big questions with regards to how you should approach the security. At least that's my approach, right? The other thing is that scanning and gathering information about your potential target company or whatever else today takes literally seconds. In some of the cases, obviously, if you want to be extra careful, it can take hours or days even. But at the end of the day, I just did a test. Mass scanning the entire Polish IP address space takes around 15 minutes if you have a pretty lousy internet connection, right? 50,000 packets per second is essentially each and every within the reach of the DSL line, DSL connected internet line. If you have access to some cloud-based services, the entire internet can be scanned within around that kind of time, if you really want to. And that's actually a completely different discussion. We will follow up on that later on, maybe not during this presentation, unless there will be question. But anyway, this is something that needs to be taken into the consideration if you are organizing anything ad hoc with regards to security architecture. And at the same time, if you believe that you don't have actually anything worth abusing, just remember that everything is essentially open or potentially a vector for abusing. The recent attacks on bandwidth stealing, the internet connectivity are kind of amazing from the perspective of trying to do anything with that. But at the end of the day, if you think about it, it's just a value that somebody is willing to use and somebody else is willing to pay for, right? So if you are doing that kind of thing, you are bandwidth sharing with the rest of the internet, somebody may at the end of the day start to abuse this. So let's focus on the transport, right? Let's go back to the agenda and let's focus on how we can tackle and protect the transport. What's the first problem? The first problem is that if you are thinking about worldwide internet connectivity, you will likely see that there is a very thin line between the outage and the attack. Actually, in most of the cases, initially the attacks on some kind of infrastructure or services are typically interpreted as simply an outage. If it lasts for extended period of time, somebody will start to look or talk about and may find that actually you are thinking about or you are dealing with some kind of attack, right? That you cannot contain or cannot unfortunately sustain. And then it's maybe an outage because suddenly you not only are dealing with attack, you just lost your data center or whatever else, right? And this is just an example of the latest statistics from 2021, and you can see that this is not something, the outage within the internet. And outage here is defined as some service provider, autonomous system, or some kind of bigger company, as you can see, either the network, which is the service provider, or public cloud, which is obviously the public cloud provider, is experiencing extended loss of service with regards to whatever they are offering. Is pretty common topic. Almost like in every given moment, somebody somewhere around the world is having some internet connectivity problems. And in some of the cases, obviously, this is just the outage, right? Somebody cut the fiber, somebody data center is on fire or things like that. But at the end of the day, some of the incidents end up being classified as attacks, right? And the problem here, that at least the problem we are dealing with today during this presentation, is the fact that in some of the cases, those will be true attacks, right? And let us consider one of the examples of those attacks, and this is some kind of topology that shows a couple of autonomous systems connected together. Typically, autonomous system belongs to it's a kind of logical concept tied to how internet works, and typically autonomous system belongs to company. Some of the companies obviously have number of autonomous systems because they are using this for different functions. And as you can see in this example, we are autonomous system 451. Of course, the numbers are just examples. Please don't use them unless you are dealing with a lab that is not connected to the internet. And we have a pretty nice drawing of a couple of autonomous systems connected together, and they are exchanging the traffic. Essentially, BGP protocol is the protocol that ties everything together and is used to advertise availability of access to a specific prefix. So if I'm owning 45.1/16, I can advertise using BGP. Hey, folks, if you want to reach anything within this address space, please connect to me or send your traffic towards my routers. And you see on the right side of the screen that we have three services, right? We have www service, which is located under 45.1.05, 06, and 09, couple of different services, and also obviously users connecting to that. So unfortunately, the way the internet is built, or the way the BGP was initially thought, moved the trust directly to the people that are operating those routers. So if you are thinking about saying, okay, this is the internet, it is working, but I want to abuse some of the services, it's pretty easy, or until recently, it was very easy to abuse the trust relationship between the folks that are handling those routers. And how? By using routing, right? By using BGP, and by using the fact that if you are a router and you are peering with someone else using the BGP protocol, you can actually start to advertise prefixes that are not belonging to you, right? So let's assume we have this malicious actor here in AS 666, and those folks typically do have their own address space, or maybe they already stole it from someone else. This is not the most important part of the story, but at some point in time, they will decide, okay, folks, right now we will start to advertise more accurate prefix or longer prefix to the destination that is of special interest for us, right? And as you can see, while we as a victim in Autonomous System 451 are essentially advertising a pretty broad space, right? /16 for IPv4. Those guys are actually announcing a more specific prefix, which means that when each and every router will make a decision about routing this traffic, they will decide, okay, the more accurate or more specific prefix will be more important for us, or more attractive than any other prefix that we see. And obviously the traffic will be, or the advertisement will then be flooded across the BGP ecosystem with the Autonomous System 666 suddenly as the owner of the /24. And this leads to a pretty interesting situation. You as a victim will still be able to initiate the traffic to any kind of services that you have somewhere in the internet, or maybe somewhere within the network of your partner. But the returning traffic, if it will belong to the address space that was recently advertised by the malicious partner, will actually get back in most of the cases, because obviously that's kind of not 0-1 decision. Almost like thanks to the BGP protocol, but we don't have too much time to discuss the specific details of that. Most of the traffic will actually return to the malicious actor, right? Because he is advertising this address space, and in most of the cases, that kind of advertisement will also be widely accepted. So you have right now a situation when the malicious actor can actually intercept your communication. Unfortunately, or fortunately, internet-based connectivity is usually both ways, right? So you have to establish two-way communication to be able to exchange any kind of data, apart from just saying hi and hi back. And that's about it, because you cannot sustain the flow, right? So what are those malicious actors doing is that actually they are also redirecting the traffic, right? So apart from just sniffing the traffic and being able to record it, or maybe intercept and modify the traffic on the fly, they will also redirect the traffic and inject it back to the original destination. So the victim can actually think that he or she is talking to the service, and it may have a bit more latency than typically, but at the end of the day, it works, right? So why worry? Now, the problem that we right now describe is so-called BGP hijacking, and this is almost like a common technique used today. And we were talking about that 10 years ago, 15 years ago as a kind of interesting technique for people that are dealing with BGP. Right now, if you look into any kind of monitor, BGP monitoring, there are a couple of such services pretty popular around the world, provided by a couple of different vendors and some of the communities as well. This is essentially happening daily in a number of instances, right? You can read through a couple of examples here. Some of the BGP hijacking is happening indeed because somebody just made a mistake, right? And typically those are typos. If this is a mistake that suddenly covers a completely different prefix that you are using daily, it's hardly a mistake. Somebody was trying to do something with your prefix, and unfortunately they failed, or maybe the automation engine failed and actually advertised this prefix towards the internet, which is considered obviously a bad practice among the service provider community. So this is happening daily right now, and the problem is that the issue got hot. Right? One of the big or pretty interesting examples is China. China owns two very big service providers, the only ones that are able to operate fully: China Unicom and China Telecom. China Unicom entered the US ecosystem trying to get some more traffic towards the network. They established routers in the points of presence across the United States throughout the 2010. And then they started to pretty aggressively redirect or hijack the traffic. And I was almost like, okay, because that kind of incidents happen. But at some point in time in 2019, China Unicom started to aggressively target not only US enterprises, but they also started to target Department of Defense networks and some other networks that were pretty critical to whatever US was doing, right? And you may have heard about some of the attacks on the US critical infrastructure, stuff like that. That was almost like connected, or the end effect of hijacking some of the address space. Why? Because if you can sniff the traffic and you can actually look what's going on, how the people are logging in, what kind of information they are exchanging, attacking such network or attacking such victim is easier then. And in a kind of unprecedented situation, US FCC at some point in time in 2018 decided that's enough is enough, right? And they decided to completely remove China Unicom from US. They forbid the company to operate and advertise any prefixes and essentially provide any kind of operation for on the US soil. And what China is trying right now to do is actually they are using proxy networks, and I will show you some examples later. But you can see that in 2019, after the action was executed, they started to actually move some of the operation to proxy networks, so-called proxy networks, right? So any countries that are operating close to America, US, like Mexico, Barbados, Antigua, any kind of European service providers that can also do tricks with intercepting the traffic and then redirecting it, at least for short periods of time. So we see this daily, even in Poland, which is kind of interesting because on one side, some of the folks never learn. Recently, Pakistani Telecom, this is just the data from August, so last month, right? Pakistani Telecom again intercepted some of the T-Mobile traffic. That time, this time it wasn't YouTube, but still a pretty interesting target for hijacking the traffic. Russia is constantly hijacking some Ukraine traffic, which is kind of obvious given what's happening right now. And specifically, the prefixes belong to IT companies within the Ukraine. And right now, we are also being targeted, or Poland is being targeted. Some of the Polish companies are being targeted by the proxy, so-called proxy networks. And again, those are typically South America. Sometimes if you go through the history of different BGP monitoring services, you can also find some European autonomous system numbers hijacking Polish prefixes, which is likely a sign of times to come, right? This is something that we have to right now live with. The problem, obviously, is that we would like to stop that, right? And there is work ongoing about that with the new concept of standardizing so-called secure interdomain routing. We already have a solution to most of the problems with the PGP hijacking. We can verify the prefixes and we can verify the origin autonomous system that is advertising those prefixes. And the only problem right now is just, deploying that, right? As I will show you in a moment, this got accelerated in 2018 after those attacks in US, when it became obvious that actually, any kind of critical network within US, big network providers or big network address blocks like Amazon, Azure, or Google Cloud will also be prone to that kind of attacks, and everybody started to deploy SIDR with regards to verifying those prefixes and actually verifying the peering relationships, right? You claim to be my partner, that's great, but are you advertising the prefixes that you can advertise, right? This is obviously a big challenge for if you are dealing with transit service providers, but for end stations and autonomous systems, endpoint, handling some endpoint services within their own and actually just multi-homed to a number of service providers within the internet, this is easier, right? And it almost like can be executed automatically. So one of the things you would like to probably think about if you own any IP address space, either v4 or v6, is to go to your favorite regional internet registry and certify your prefixes. And then they can be validated. And if they can be validated, anybody in the internet can make a decision if they want to accept potentially spoofed advertisement of your prefixes, or they will drop this on the floor, right? And the more service providers are joining this kind of movement, right, or deployment of the new technique, actually, the better the chances are that your prefix will not be hijacked in the internet. And this is just one of the examples. You will see more in the offline version of the presentation. This is for iOS XE. We are still AS 459. We still have a connection to AS300 and AS400. And if you can see on the routing table, we see a prefix. And again, this is just an example, right? I'm making this up on the fly. You see that we have a prefix 2.58.228/24, and it's actually advertised by both of the upstreams from us, right? So AS300, which is typically, or for example, 3.6, and then we have the same advertisement from 4.6. Because we are running this RPKI subsystem, we see the letter here on the first column, which says V, which is verified, or I, which is invalid, right? There are essentially three states that the prefix can be validated to, either valid, invalid, or simply not found. So not certified yet, right? So if this is not found, we can still accept it because somebody or people responsible for the prefix were simply careless and they didn't certify the prefix yet. But if something is invalid, somebody is playing games, right? The prefix was signed, it is in the regional internet registry cache, but actually it doesn't meet the version that you are receiving doesn't meet one of the requirements. Either the prefix is wrong or the origin autonomous system is wrong, right? So if you implement that kind of policy that I just sketched here, right, depending on the state of validation, do something with the prefix. Once you do execute that on a routing table, the prefix that is invalid should simply vanish from the routing table. It shouldn't be actually, considered as a valid route within your routing space, which again, from the perspective of stub network, like connected multi-homed customer, doesn't make much more sense because you have to send the traffic anyway, unless you want to go the hard way and actually drop the traffic proactively, which is also a possibility. But for transit providers and big content providers, this starts to make a difference, right? And again, just a small ask for all of you, try to certify your prefixes. This is the current situation in RIPE. Almost like half of the prefixes are signed already. We are still looking for 125,000 to be certified, but this is progressing pretty nicely. And as you can see, in 2018, it started in 2019 and then it went up. Right now, there is a massive number of events and a massive number of trainings that show how easy it is to go through the certification of your prefix. Essentially, using RIPE website, it takes like maximum 5 minutes to go through certification of your own prefixes, right? And again, by all means try to do that, because you are doing a great service to the worldwide internet. Now, this will of course extend, right? We've heard recently that not only you will have more and more satellite-bound communication, some of the companies will use the satellite communication as a typical lines, because they are the places where they are operating are typically not well connected to the landline internet, or the connectivity is so poor that they have to use a couple of connections at the same time, trying to use the bandwidth of aggregate of those links, right? So one of the things that will likely happen is that we will have more and more companies operating protocols like BGP, protocols essentially for dynamic routing over the satellite links. And because you can easily spoof the traffic and can listen to the traffic, and using less and less investment in your own resources or devices, you can start to send the traffic. If you know how to do that, chances are we will see things like one in space and the same time hijacking prefixes coming in from space, which obviously already is happening or will start to happen shortly, because for the last 10-15 years I know at least about 3 different companies that are using the satellite connections and upstream connection to satellite as something that is a typical wide access network connection, right? So you can just think when you will hear in the news that that kind of connectivity was hijacked and then something was operating in this space. Now, obviously, all of that is just emanating the information in the internet, and we can think about this from the multiple directions. We are talking about securing the transport. Securing the transport means that you don't want others to listen to your communication, and at the end of the day, you also want to have a control about what kind of communication goes where, right? And the problem with the signals is, again, the fact that a lot of devices, essentially all of the devices, are right now sending a lot of telemetry into the internet to some of the services, and it's pretty popular to deploy solutions like Pi-hole or anything like that, just to try to stop all of that, right? You cannot do this anymore. If you block some of the critical services, your devices or software will simply stop to operate, or will operate in a kind of problematic manner with regards to your full feature set. But at the end of the day, this is nothing new, right? First of all, we had already situations when we were deploying new protocols like IPv6. Some of you were not deploying the IPv6, but the operating system defaults changed, and suddenly your device was automatically trying to set up an IPv6 communication. So we did set up a lot of, again, best practice scenarios and thought about how we can train, how we can inform customers and then users how to operate this technology securely, right? It's a bit of different discussion if you are dealing with end user devices. It's a bit different discussion if you are dealing with devices and software that should be operated by the integrators or companies that are actually professionally doing that kind of deployments. But at the end of the day, it's about the user or the owner of the address space and the service to make sure that whatever he or she is doing will be done in a most secure manner, right? And one of the best practice services that we did deploy, in this example I did deploy, was the copy of the AS 112 autonomous system, which is a curiosity by its own, because in Poland, if you know, we have a number 112, and this is emergency number, and there is no connection between those two. That was established way before. And the thinking here is that because your root servers or your forwarding servers, DNS servers, will be likely sending some reverse queries towards the root servers, and if the root or reverse query is about private IP address space, it doesn't make any sense to actually send it anywhere because it cannot be answered. You should be trying to keep this traffic local, right? You shouldn't be sending this towards the internet. Unfortunately, in most of the cases, the default configurations from most of the Microsoft-based systems, for example, do that. And this is potentially also one of the interesting information gathering exercises when you can intercept that kind of communication and see what kind of queries are being searched for this company or by this company, by DNS servers of this company. DNS for the last couple of years became a very interesting intelligence gathering protocol. So right now we are also trying to do something on a community-based basis to actually stop it, first of all, and obviously also to contain to some extent the number of queries that are being targeted to the root servers, right? Essentially, AS112 is any casted service run by the volunteers. And you can think about this service as a kind of sinkhole, right? We are not responding to the queries. We are just advertising the address space and try to contain this flood of packets. And this is the statistics from the servers I'm running. There is an instance for AS110, 1 and 2, sorry, established a long time ago by Applet folks, and a shout out to them with regards to running the service. I did set up 4 instances, and I would like to thank Atman and Epix for providing the free colocation facilities to doing so. But anyway, you can see that there is a lot of queries happening in a normal day. In some of the cases, when we see some additional traffic, for example, during the attacks or DDoS attacks, stuff like that, the amount of traffic being sent towards those servers is a bit bigger. But typically, they don't cross about 250 queries per second, each and every server out of the 4, right? So you can see something about the scale. And this is just a capture from August 15, when I was observing what is going on one of those servers. So you can see an example of some of the requests that are coming from potentially also your address space, right? So watch out for that, because obviously at the end of the day, there is no easy way I could potentially use this information, but and this is not a best practice, right? Sending the information about your internal queries to the internet just because your DNS servers are misconfigured, right? Potentially, you could start to map in internal address space. Obviously, this will be time-consuming, and likely just attacking the application would be faster. But anyway, this is considered a bad practice. In some of the cases, you can see 2 places here when I did use blue blocking square. This is the situation when the name of the request is actually coming out. Somebody is looking for a very specific company-like name that, again, shouldn't likely hit anything outside of your internal network. And, you know, as service providers are doing that kind of exercises from time to time, and again, kudos to them that they are, you know, willing to spend time on stuff like that. But I will be also trying to reach slowly to some of the companies with the example of the communication, asking them to, you know, implement the best practices along with the short links to how to do that on a different DNS servers. I'm happy to say that in most of the open source servers, like Unbound, for example, that kind of requests are handled internally, and they are not forwarded by default to the internet. So in most of the cases, unless you did misconfigure something seriously wrong, you should be fine, and you shouldn't be worried about the telemetry coming from your network. Now, the last thing I would want to tackle is this dark communication that we discussed initially with Adam. And this is the new trend that is actually, you know, spending most of the time of folks dealing with network security taking most of the time for folks dealing with network security during the last, I would say, decade, in terms of how we should tackle that. The problem is that obviously old version of SSL, or essentially all versions of SSL and the old versions of TLS were already depreciated. But if you look into your traffic, first of all, some of your devices and services will still use it, which is unsafe. Second of all, your malware that is attacking you or operating within your address space or trying to horizontally spread across your entire infrastructure is likely also using encryption. Why? Because if you are using encryption, there is an additional cost of decrypting the traffic and then inspecting it. In some of the cases, you simply cannot decrypt the traffic because you don't have any keys, right, to do so. So there are a couple of strategies here. I don't want to go into details how to deal with that in terms of, you know, defining a strategy or defining a policy. Just wanted to make a couple of points and then offer some guidance, right? So first of all, a lot of devices will use depreciated TLS versions. And this is, as I said, unsafe. What's funny is that a lot of different devices that can be connected over Wi-Fi surprisingly are also using TLS for communication. I haven't seen recently anything using SSL, but some of the, for example, Philips beamers are using TLS 1.0 to contact the mothership, right? Which is interesting because if you can intercept that kind of communication, it happens over Wi-Fi, so it happens over radio. You can do likely some interesting stuff. This is not my domain of work, but that kind of protocols can be easily attacked. They are vulnerable to a lot of different interesting attacks with regards to the logic behind how the sessions are established and how the ciphers are being negotiated. And then you can likely just be the mothership for this Philips beamer and then start to do funny things during the corporate presentations. The same happens with the equipment we are using at home, right? Some of the Samsung TVs, and this is, for example, not the only, of course, the vendor that has that kind of problems. But what's interesting, at least for me, is those are the TVs that were both like a year ago. This is not a TV that was both 10 years ago, and it has the first internet connectivity Ethernet jack or something like that. No. Those are pretty new TVs with upgraded firmware and stuff like that. And sometimes those those devices will be talking using depreciated standards. So watch out for that, because obviously you can be owned in a number of ways, almost like unlimited numbers of ways. One of the things is just entering your home network or your branch network and then propagating laterally within that infrastructure, jumping to more and more important devices across your network. And the funny thing is we are going through the way that we were already in, right? Because initially when we were talking about my endpoint will connect to your service, we were not encrypting the traffic at all. Then we decided, okay, this becomes a really bad word for the clear text communication. Let's try to encrypt the traffic and authenticate the traffic, right? Then obviously the vendors like Cisco, for example, I'm working for, came saying that, folks, this is the network as it is can bring some important services to the traffic that you are sending. So let's inspect this in a kind of man-in-the-middle type of interception, and then do all kind of policy stuff, right? Let's apply firewall policy, let's apply IPS policy, let's apply anti-malware, stuff like that. And this is actually the situation we are right now, because at some point in time it was decided, okay, let's push all of the traffic through those middle boxes, because they will provide us with some specific policy enforcement capabilities. But the problem is, obviously, right now with TLS 1.3, that in some cases when you are doing things like certificate pinning and stuff like that, it is no longer possible, if the endpoint is properly managed, to do that kind of interception. And more applications are actually embedding the certificates and enforcing mutual authentication of the sessions, right? So the problem is becoming that the problem is starting to be the fact that you cannot actually rely on the middle box to inspect the traffic, because in some of the cases, the application will be truly end-to-end encrypted, and you can break this, but you cannot intercept this in any meaningful way. The problem here is that in some of the cases you have to, right? In some of the places where you are working, like a banking sector or energy sector, any kind of critical infrastructure, you will be looking for ways to enforce some specific traffic policy scenarios. And in such cases, that kind of connections has to be downgraded, or by managing the certificates centrally and controlling who can access what, they will be essentially kind of, downgrading the overall security posture from end-to-end encryption to end-to-middle box to and service point encryption. But if you look at the problem from the last, I would say, 20-25 years of time, you can see that essentially we bounced around, right? We moved some of the effort to the endpoint, then we moved some of the effort to network to scale the effort, because obviously we moved from 1 megabit to 10 megabits to 100 megabits. then to 1 gigs of traffic. Right now, we are talking about 10 gigabits of traffic, 40 gigabits of traffic, 100 gigabits of traffic, and in some cases 400 or 800 gigabits of traffic, right? Which is kind of problematic to handle even for a network dedicated accelerators. So this is the situation where we're in. We are bouncing between the middle boxes doing stuff and endpoints doing stuff. Right now in 2021, it seems that the endpoint is the focus point. This is where the session starts, and in some of the situations, it will be the session, it will be the place where actually we only have the only place where we have full visibility into what is going on the process side, and that is generating the traffic, the network itself before, or the network traffic itself before it is encrypted, and then when it's sent over to the service. So it has to be acted upon, right? There are a couple of interesting proposals how to offload the encryption to the network or to some kind of accelerator or to some kind of function that will be allowed to intercept the traffic or inspect the traffic. But again, if we are thinking about privacy, that's almost like an end goal, right? You don't want any middle box to intercept your traffic. If we are thinking about enforcing the traffic in an enterprise, that's kind of nightmare scenario, right? Because at some point in time you can become blind. And this is exactly what I thought about when I said dark networks, right? First of all, the middle boxes obviously can be attacked as well. There is a great recent study done by folks from University of Maryland and Boulder that actually shows that some of the DPI, IPS, and load balancers can be actually attacked, and they can be used to amplificator to reflect amplificator attacks as well, right? Which is a scary story by its own, right? But it's kind of obvious for anybody that is dealing with security that if something is doing something with the traffic, likely it's also an attack vector at the same time, right? If you are good enough to try to attack it. The other problem, and sorry for that because it seems something is wrong with the switching. The other problem is that unfortunately, immediately after the problem was identified, that we have a lot of encrypted traffic and we cannot deal with that at scale, malware started to use encrypted traffic, right? One of the interesting ideas was to try to then apply some fingerprinting on the encrypted traffic and say, okay, this also, we cannot decrypt the traffic, but we can fingerprint it. And once we did fingerprint the traffic or the initial setup of the session, we can say with pretty high confidence that actually this is a malware, right? Because it looks like a specific strain of some malware that was used in an attack that we know already about, and it was also using, for example, TLS 1.1 or whatever else, right? So there is an interesting development effort. There was an interesting development effort done by the engineering team at Salesforce. They built a JA3, JA3S for the server side of the library part. They built an interesting library that is actually doing the fingerprinting on the fly. They even did publish online the fingerprinting database because, again, the data is usually the most important or stuff that we can offer. But unfortunately, if you are just using single metric to measure if this is a malware or not, you may be easily misled. This is just an example of that, and the quality of the data that you are gathering in the databases will be very important, right? As you can see, this is an online test done yesterday on this site with the fingerprint, but this is I was using the Brave browser, right? You can see that the fingerprint was identified as Firefox across different operating systems, again, none of which matches what I was using at the time, which was a Mac OS. So unfortunately, the only doing fingerprinting using single set of data may not be enough. That's why, for example, at Cisco and some other vendors are obviously doing this as well, we not only do the fingerprinting of the traffic, we also do analyze some of the behavioral data, and then we match the traffic for other services, with other services, like, for example, our DNS intelligence solution, which is Cisco Umbrella. And this gives us much better information about, okay, seems like this is a host that is using encrypted connection, and on the the first sight, it would look like it's a malware, but actually, if we correlate all kind of different data we have, all kind of different metrics that we have about the traffic, doesn't seem so, right? It looks like almost like a malware, but at the end of the day, it seems that it's just a, for example, point of sale application behaving in a kind of unusual but still controllable way. And this is the example of the open source. So obviously you don't need to use at this moment Cisco solution, but at the end of the day, you can play with that kind of things. And we as Cisco also published 2 open source projects. First one was Joy in 2018, I believe. Right now, recently, we also released Mercury. And those are the parts of the story, right? So if you want to do a collection at scale, you have to do this in the access. And that's why we are using our switches, access points, and routers to actually collect some of the data. And the same data you can collect yourself by using Joy or Mercury, right? This is just an example from Mercury package when we are generating those fingerprints from the encrypted traffic. Obviously, you have to have the backend that will store this data and then analyze this data using any kind of machine learning or unicorn specific artificial intelligence that Adam was referring to at the beginning of the session. But still, it's a good start, right? At least you can see what kind of traffic goes through your network and start analyzing this later on. There are a couple of interesting industry examples of trying to deal with the problem. Now, this is just a show, just a picture of information or correlation advantage that you get when you start to correlate different sources of information, HTTP headers, DNS intelligence, and at the end of the day, everything together along with the TLS fingerprint. And you can come up with pretty interesting confidence, like 99.8%. Typically, when you read through the white papers available all around, and this is just a selection of them, again, you will have links in the PDF file, you will see that the confidence grows if you are using multiple sources of information. At the same time, if the author of the white paper is just using a single metric or set of metrics on a given traffic, when the traffic data set is changing, usually the confidence again goes back to like 50-60%, which is almost like, you know, usable from any kind of practical things. So in summary, where are we going and what are we looking forward to? So first of all, right now it seems that we are fighting a big battle about privacy, and obviously TLS encryption and searching for malware in TLS encryption will be part of it. As you've heard recently in the news, Apple decided to roll out, actually they did roll out this years ago, but we didn't know that. But right now they wanted to implement this full scale. They stopped this effort because both the cryptologic community and some of the folks that are pretty active in the space started to ask hard questions, how the information will be used. But this is a kind of problematic in terms of living in a country when that kind of hash can actually decide if you will be in prison or not. We are working in the internet space, right? We consider ourselves folks that are building the internet solutions. So if there is something that we cannot really solve, we should just try harder and look for other ways to achieve the same, right? The same, and this is exactly what is happening right now in both of the topics I was talking about. So one was transparent transport security, when we need to find the ways to actually validate who is advertising the address space and from where they are advertising this, and also looking for signs of malware in encrypted traffic. And to be scalable, we cannot really rely on being able to decrypt everything, right? It will be more, or it will be less and less actually feasible going forward, because the encryption will grow stronger. And at the end of the day, some of the companies are already experimenting with their proprietary encryption. Big content providers, I will not name names right now, but you can think about who is trying to control your smartphone if this is not just a vendor of the smartphone. So we should be looking to implement stuff that is already known. That's one kind of key problem, because in most of the cases, that kind of best practices are not implemented. And then we should try to follow the principle of least privileges, right? Some folks call it zero trust architecture, when you simply assume that there is no communication allowed until you are able to define a policy, then use multi-factor authentication or strong authentication to authenticate all kind of sessions. But at the same time, things that did work for 20 years and are still working today, things like layered defense and deploying that kind of services should be on top of your list of things that I need to implement immediately in my network to avoid being owned by ransomware or simply being owned by somebody out there in the internet. And last but not least, there is a growing amount of publications about Polish internet and the security space within security space. So I encourage you to look through those and read through them, because they all often contain a number of important or at least interesting information. At the end of a typical vendor presentation, you will see a lot of white papers sponsored by the vendor. So I'm not going to do that right now, but I would like to ask you to go through those reports and see what is happening in the Polish internet, and just subscribe to whatever is happening in this space to be aware of what is happening in this space, right? And with that, thank you very much. Sorry for keeping it a bit longer than it was planned. I hope that was at least interesting opening session for stuff related to network. Adam?